Welcome back. In this video, we are going to solve problem 4-88 that is taken from chapter number 4, Axial Load, and book name is Mechanics of Material by R.C. Hibbeler. And the topic which we are covering is stress concentration. So statement is if allowable normal stress for the bar is 120 megapascal, determine the maximum axial force P that can be applied. So you can see this is the bar that is subjected to axial load P, and the allowable stress for that bar is 120 megapascal. So you have to determine this P load. Now you can see from in this figure we have fillet as well as hole in this bar. So what we are going to do is we will find the P for fillet as well as for the hole. So let's start with the solution. So we know that maximum stress or allowable stress both are same. This is equal to stress concentration factor multiplied by sigma average. So what we are going to do is that for fillet we will find the stress concentration factor. So I will write for fillet we will find K. Clear? How we'll find K? You can see this graph that is available in chapter number 4. So I have taken that from that portion. So for finding K, we need R by H and W by H. So what will be W by H? I will write W by H and R by H. So you can see W here is this one. So R is this one, which is fillet radius. Height is the R. H is the minimum height of this portion, and T is the thickness. Clear? So here what we are going to do is that we will find W by H. So W is 40 and H is 20. So 40 divided by 20, which will give us 2. And now we'll find R by H. So radius of fillet is 10. So I will write 10 divided by H is 20 millimeter. So 20, which gives you 0.5. Now W by H is 2 and R by H is 0.5. So using this figure, you can see this is 0.5. If I draw vertical line, so you can see it will cross this W by H is 2, which is this graph. You can see this graph, and that is intersecting over here. So if you take a horizontal line that will intersect y-axis, and K will be 1.4. So what I will write it over here. K is 1.4. K is equal to 1.4. Now what we will do is that we will find the average stress due to this load. So we know that average stress is equal to P divided by A. P is not known, and for this portion you can see this will be the cross-sectional area. So height is 20 millimeter and thickness is 5 millimeter. So we will convert it into meter. So area will be equal to 0.02 multiplied by 0.005. Clear? And we also have allowable stress, which is 120 megapascal. So you have both three values. So put it, allowable stress is equal to K into average stress. So 120 into 10 raised to power 6 Pascal will be equal to 1.4 multiplied by average stress is P divided by 0.02 into 0.005. Clear? As we are interested to find out P, so P will be equal to 120 into 10 raised to power 6 multiplied by 0.02 multiplied by 0.005 divided by 1.4. So when you calculate it, you will get P will be equal to 8.57 kilo Newton. Now this load P is due to this fillet. We will now move toward for finding hole. So for hole, again we have maximum stress or allowable stress is equal to K into sigma average. So we will first find this K. How you will find this K? So by using this graph, because this bar contain hole. So for that we will need this 2R by H. So 2R by W. So what is 2R? 2R is this diameter of hole, which is 20 millimeter, and W is 40 millimeter, which is this height of maximum bar. So I will write 20 divided by 40. and that will give you 0.5. Now you can see that 0.5 is this point. If I draw vertical line, it is intersecting this graph at this point. And if you take a horizontal line from this, so this will be your 2.1 will be your K. So K is equal to 2.1. Allowable stress is already given, which is equal to 120 megapascal. So 120 into 10 raised to the power 6 Pascal. So we will find sigma average. So we know that sigma average is equal to load per unit area. So load which we are calculating, or we want to calculate, divide by the area. So you can see this bar contain hole. So what will be the cross sectional area? So this cross sectional area will be this W minus this hole into this thickness will give you this cross sectional area. So W is 40 and thickness is 5 and diameter of hole is 20. So I will write 0.04 minus the diameter of hole, which is 0.02, into thickness 0.005. So you can see you have value of K, allowable stress, and average stress. So just put it in this formula that allowable stress is equal to stress concentration factor into sigma average. So 120 into 10 raised to the power 6 is equal to 2.1 multiplied by P divided by 0.04 minus 0.02 into 0.005. Clear? And from here you will get P will be equal to 120 into 10 raised to the power 6 multiplied by 0.04 minus 0.02 multiplied by 0.005 divide by 2.1. So what we will get is that P will be equal to 5.71 kilonewton. Now this is the P load applied, or allowable P load that can be applied to hole. Now we have two value. One is this and another one is this. So we will choose the smallest value. Why we will choose the smallest value is 5.71 kilonewton, and the reason why we choose this smallest value is because it will be safer and that can be applied. So if you apply this force that exceed the allowable stress in this bar, and this will fail. And that was all about this problem 4-88. I hope you have enjoyed this video and you have learned from it. Those who are new to my channel, then subscribe it and don't forget to press the bell icon so that you can get notification about my latest videos. If you have any question, you can ask me in comment section. Also share my videos with your friends and help them in learning as well. Thank you for watching.